In few minutes, I am going to give you the answer of a very important question. And what is that question? The question is, can we define the temperature of vacuum? Have you understand? Can we define the temperature of vacuum or free space? The answer is yes. We can measure the temperature of vacuum. But you will get surprised that temperature, which is called measure of average translational kinetic energy of a system. But if you define the vacuum, how you can define it? Actually, vacuum is defined as a space with no matter or no radiation. So if you talk about a perfect vacuum, then that will be a space which contains neither matter nor radiation. In other words, it is also said that vacuum is a space with such a little pressure that whatever particles throughout the space have had no effect on any activities taking place. It means if you assume that there is some particle inside the space, those particles are not in motion. So in this way, as you know, the definition of temperature in accordance with kinetic theory of gases is it is the measure of average translational kinetic energy of the molecules. But since a perfect vacuum does not contain any molecule, and even if when it contains a molecule, we assume that the molecules are not performing any activities. It means the molecules are not in motion. So according to this definition of temperature and vacuum, we simply say that the temperature of vacuum must be zero. It means it must be 0 Kelvin. Okay? According to this definition. But you have definitely studied the third law of thermodynamics. And according to third law of thermodynamics, this 0 Kelvin temperature is not possible. It is impossible. Okay. So if you talk about in terms of the third law of thermodynamics, then you must say that the temperature of vacuum cannot be 0 Kelvin because 0 Kelvin temperature is not possible. So some people think that in this way we can say that we cannot define the temperature of vacuum. So there is some people also give argument that actually the temperature of perfect vacuum is undefined. So there are two aspects. Either we will have to take the temperature of vacuum equal to 0 Kelvin or it may be said to be undefined. But what is the real scenario? Actually, if in this condition we can conclude that either there is not a perfect vacuum. If there will be some temperature of the vacuum, it means the vacuum is not perfect. There is some particle or radiation inside it. And even if there were a perfect vacuum, then its temperature must be equal to 0 Kelvin. So finally, we conclude that temperature of vacuum must be 0. When you say must be 0, it means its temperature must be equal to 0 Kelvin. Okay. So whenever this question will be asked to you in any interview or as an objective question, what is the temperature of vacuum or how we can define the temperature of vacuum, you must say that temperature of a perfect vacuum is 0 Kelvin. I think your doubt about the temperature of vacuum has been cleared. Okay, thank you very much.